Good morning all. Today we are going to discuss module 2 of ocean wave hydrodynamics. So these are the topics covered in module 2. So it is believed that ocean constitute about 70% of the surface of the earth and about 97% of the water content of earth belongs to the ocean. And the ocean is rich in natural living and non-living resources. So in order to explore and exploit the vast non-living resources like oil, gas, mineral, etc., we require a variety of structures which is to be designed and installed. So now we will see in detail what are the different types of structures in the marine environment. So the structures in marine environment are broadly classified into coastal structure, port and harbor structure, and offshore structures. So the offshore structures are used to explore the oil, gas and mineral from beneath the ocean floor. So the figure shows a drilling rig. It's a machine which creates a hole in the ground for extracting the oil and natural gas, which is a semi-submersible one. So oil rigs are large structures that extract oil and natural gas from the ocean floor. So this helps to meet the demand for the oil and gas. There are different types of oil rigs. So in the next figure you can see a fixed platform rig. The next is a jack up rig, and this is a drill ship. So these type of structures are classified into fixed structure, movable structure and complementary structure. So these can be fixed to the ocean floor or may float or may be supported by artificial islands. So this is also an offshore structure. This is a wind farm which is used to generate electricity. So it is located in the sea. So the stability of these type of offshore structure are affected by the lateral force exerted by the wind, force due to tides, wave and current. So the marine structures are analyzed not only for the static and dynamic load but also the structure reliability analysis should be considered. So when we consider the marine structures, it suffers from corrosion due to chemical process, collision by ship, and can be damaged due to unexpected disaster. But among the environmental conditions are severe. So we have to focus more on the waves, the force due to the waves, current and tides. So next is the coastal structures. The coastal structures are mainly needed to prevent the erosion by wave action. So the first one is the sea wall. So sea wall is a coastal defense structure that separates the land and water. It protects the land from forces of waves, tide, tsunamis, etc. And these type of structures are built parallel to the shore and can be vertical or sloping. So it is used in area where the shoreline is at the risk of erosion. And the next one is the bulkhead. So bulkhead protect against water damage and shoreline erosion. It is mainly constructed with concrete or large boulders. it reduces the land erosion. Next one is the groins. Groin is built in order to reduce the shoreline erosion by means of controlling the rate of along shore or littoral drift of the beach material. So littoral drift is known as the longshore sediment transport, which is a natural movement of the sand and other sediments along the coast due to the wave action and the current. So groin is an active structure extending from shore into the sea, most often perpendicularly or slightly oblique to the shoreline. So next is the breakwater. These are man-made structures built to protect the coastal area against waves, current, tide and storm surge. It protects the harbors, anchorages and the marina basin from the waterways, and it reduces erosion. So they attempt to break the incoming waves before they reach the shoreline or the marina they are protecting. So this figure shows the breakwater. So next is the revetment. So it protects mainly against erosion and wave action, and it is provided to improve the stability of the slope of the shoreline. In this figure you can see riprap revetment, which is made of stone layered in various sizes with the largest stone on the outside and the smaller one underneath. So this helps to absorb the impact of the flowing water. The next one is the harbor and port. The harbor is partially enclosed area which prevent safe and suitable accommodation for supplies, refueling, repair, loading and unloading of cargo. And port is a place which regularly provide accommodation for transfer of cargo and passengers to and from the ship. So port include harbor plus storage facility plus communication and other terminal facilities. So next is a wharf. The wharf is a structure supported on piles and constructed along a river or a sea that facilitates safe berthing of the vessel. So in the wharf, ship may lie alongside to receive and discharge the cargo and the passengers. The next is a quay. Quay is generally erected along the river bank or shoreline where it is ideal for the purpose of docking. Next is the pier. So pier is a berthing structure that runs perpendicular to the shore and projects out into the water. So it provides berthing of ship on both sides. And the next is the jetties. Jetties are structure projecting into the water. The jetties may have berth on two sides and abut land over the full width. And the next is the moles. These are rock fills extending out from the shore. The top surface of the structure provides facilities like a roadway, railway track, a sidewalk, etc. These are more economical than trestles in water having depth of 3 meters. Next is the dry dock. It is a chamber provided for the maintenance, repair and construction of ships. It includes walls, floor and gate. And the next one is the wet dock. So wet dock is used for loading and unloading cargo and passengers and for regular maintenance and repair. So due to the variation in tidal level, an enclosed basin is provided wherein the ship can be berthed, and it has an entrance which can be controlled by a lock gate. So now these coastal structures are very important because they protect the harbors and inlet, and it protect the shore-based infrastructures, and it provide beach and shoreline stability. It stabilize the navigational channel. It protect the navigation coastal communities, then provide flood protection and provide recreational activities. So in order to design this type of marine structures, we have to understand about the tides, waves and currents. So these environmental parameters are very important in the design of the marine structures. So now we will see in detail what is current. So current is a flow of mass of water due to the existence of the gradient. So gradient is the reason for the current. And the gradient can be caused due to change in salinity, density, temperature, pressure, wave height, tidal waves, etc. So the ocean current are broadly classified according to the forces by which they are created, the time of appearance, the locality and the region in which they are situated. So the first one shows the classification of ocean current based on the forces by which they are created. So second is according to the time of appearance, and third one according to the locality, and the last one according to the region in which it is situated. So the information about current are essential because current exert forces on the structure, and also the characteristics of wave are altered by the presence of the current. So next we will see what are waves. So waves are periodic undulation of the sea surface. It is caused by the action of wind over the water surface. So when you put a stone into a pond, we can see the generation of waves from the source point. The same waves can also be generated due to earthquake, which will cause tsunamis. So this wind pump in energy for the growth of the waves. So the motion of the waves are considered to be oscillatory. So we can call the wave as oscillatory waves, or it undergoes oscillatory motion. So what are the causes of waves? So waves are mainly created by the release of energy or disturbance, which include wind, movement of the fluid of different density, then mass movement into the ocean, that is splash waves, underwater seafloor movement, that will create tsunami, the full of moon and sun, that is tides, and human activity. So these are some of the causes of the waves. So these are the different parts of a wave. So we can see wave crest, wave trough. Wave crest is the topmost point of the wave, and wave trough is the lowest point, and wave height, wave length, and now we have this terminologies of wave, that is wave steepness is equal to wave height divided by wave length. If the steepness exceed 1/7, the wave will break. Then the wave period, it is the time it takes one full wave or one wavelength to pass a fixed position. It is denoted as T. Next is the frequency. Frequency is denoted as F, that is equal to 1 by T. So now we will see the generation of the ocean waves. So wind acts towards the water surface, and the forces from the wind causes normal and tangential stresses. So initially small waves are generated. As wind continues to blow, more and more energy is transferred and the wave increases in height. So the size and the type of the wind generated waves are mainly controlled by wind velocity, wind duration, fetch, and the original state of the sea surface. So as the wind velocity increases, wavelength increase, period and height increases. So the characteristics responsible for the growth of the wind are: first one is the fetch. Fetch is the distance over which the wind blows. Second one is the wind velocity, and third one is the duration of blow. So now within the fetch area, when the energy is continuously being transmitted, which is helping in the growth of the waves, or the sea state goes on increasing, which is known as the partially developed sea. So this is a very important definition. What is meant by partially developed sea? So within the fetch area, when the energy is continuously being transmitted, which is helping in the growth of the wave, that is, the waves are in a growing stage, that is known as partially developed sea. And seas is the term applied to the sea state of the fetch when there is a chaotic jumble of the new waves. And a stage will reach when energy from the wind no longer helps in the growth of the wave. Such a state is known as the fully developed sea. That is also a very important definition. What is meant by fully developed sea? A fully developed sea means the wind generated waves are as large as they can be under current, wind velocity and fetch. That is, it is the maximum height of wave produced by the conditions of wind speed, duration and fetch. And the significant wave height of this particular situation is the average of the highest of 1/3 of the wave present. And this is a good indicator for the erosion of the shoreline and wave damage that is occurring to the ship. So fully developed sea and partially developed sea state. So these two definitions are very important. So now we will see what is wind. So one of the important factors in the design of marine structure is the characteristics of the wind blowing over the ocean surface. So wind velocity is usually referred by Beaufort scale that ranges between 0 to 12 and can be expressed as V is equal to 2.99 root of d cube, where V is the wind velocity in kilometer per hour and B is the Beaufort number. Wind speed is measured in 10 meter above the earth. So Vs is equal to V10 into S by 10 into 1 by 7. And the pressure intensity P is given by C into V square, where C is equal to 0.00481. And the total force due to wind is given by Fw is equal to K suffix SF P into A. So here P is the pressure and A is the area, and K is F is the shape factor, which is varying between 1.3 and 1.6. And the wind data is usually presented in terms of the percentage of occurrence of wind intensity in a particular direction, either monthly, seasonally or annually. And these are some of the empirical relation to estimate the maximum wave height. So H maximum is equal to 0.026 V square, and H maximum is equal to 0.0555 root of V square F, and T maximum is equal to 0.5 into V square F whole raised to 1 by 4. Where H maximum is the maximum wave height in feet, and capital F is the fetch, and T maximum is the maximum wave period in seconds.